All right, what we have here is we're going to talk about 5.3 day 2 conditional probability and independence, and specifically we're talking about some notes on tree diagrams. Now, when we talk about tree diagrams, um, we have a tree diagram which takes a chance behavior where we have a probability of a event happening, and then we have the probability of a event not happening. Now there could be several other events that possibly could be determined here, but what we then have is that if A happened, given that A happened, B or C or D may occur. And so what we have is essentially we are looking for what is the probability of A and B happening. Now to figure this out, we're going to use what's known as a general multiplication rule. And what we know of this is that understanding that if we have probability of A and B happening, if A and B are independent, we know that probability of A equals probability of B given A. Understanding that the probability of B, and if we write this out right here, we know that the probability of A and B over the probability of A, that is going to be our solution. So what we know is if we can take the probability of A times the probability of B, that would give us our value for the probability of A and B. And so right here, in our front, figure out the probability of A and B, we can simply just multiply these two values together because in this given statement, all right, probability of A and B, we can actually multiply the probability of, well, if these are independent, we can just multiply those two values together like so. Or if we have a tree diagram, we know that in order to find this A and B, we can multiply these two values together because when we have a probability like this, this is actually equivalent to, as I said before, is equal to the probability of A, or actually B given A. And so multiplying these two together with the probability of A and B, which equals the probability of B given A times the probability of A. And so that's how we can use a tree diagram to figure out what the probabilities of both A and B, or A and C happening, and A and D happening, and so on and so forth. So we're finding these out by using what we know about conditional probabilities in this formula. We can also use that for independence, and if we want to figure out what the probability of at least one thing happening, we can have 1 minus p times the probability of none of the things happening. Now, all of this is a lot of information, kind of running around in a lot of different places here. I apologize. But what we have is a general multiplication rule, and we have tree diagrams. And what we know about with tree diagrams, as we figure out all of these end statements, all right, we know that all of them should add up to equal to 1. So let's check out a problem to see if we can help with this. So a computer company makes desktop, tablet computers at factories in 2 states, California and Texas. California factory produces 40%, and I'm going to say California, all right, 40% of the computers. And the Texas factory, all right, that factory produces the rest. So that's going to be about 60%. Of the computers made in California, 25 are laptops. So California, we're going to call this laptops. We're going to call it A. We know it's going to be 25%. We know the desktops, we'll just call it D. Desktop is going to be 30%. And the rest are tablets. All right, so if we add those together, we know that's going to be 45%. Okay, 45%. Of those made in Texas, 10% are laptops. Right there. We know that desktops, D. So I'll put that as T, tablet. All right, D right here is 20%. And the rest are tablets right there. So we know that's going to equal 70. 70% are tablets. All right. Now, in both of these have to be added up to be 100. So all the computers are first shipped to the distribution center in Missouri before being sent out to the store. Suppose we select a computer at random from the distribution center and observe where it was made. That's not okay. So we want to construct a tree diagram, and I just did that as we're going through. Okay. And so as we have a chance process, we have some sort of computer. Okay, so we have our computers, and they either were made in California or Texas. 40% in California, and of these 40%, we know laptop, desktop, and tablets, and together, right here, okay, right now, that's what we have there. So now, if we wanted to figure out what this chance process is, we could figure out the probability of a computer being made in California, all right, and being a laptop, and we could figure out all those different values. We could just multiply those two values together. So that would be 0.4, all right, times 0.25. Now, just to recall, why are we doing that? Because this right here, this is the probability of a computer, all right, being a laptop, given that was made in California, all right. This is the probability of being a desktop computer, given it was made in California, and so on and so forth. And so to figure out this probability, we're going to be taking the probability of a computer being made in California times the probability of the conditional probability. And so that is what's going to give us our combination, which is going to be 4 times 0.25. And if you want to check all these out, you can probably do all those same. So, and right here, what's the probability of being California, all right, and the desktop, and we would take 0.4 times 0.3, and that's going to be 0.212. Probability of California and a tablet, once again, 0.4 times, all right, 0.45, and that's going to be 0.18. All right, now we can go down here and say, okay, what's the probability of being from Texas, all right, and being a laptop? Going through the same thing, because this is the probability of being a laptop given that was made in Texas. And everything's made bigger in Texas, right? Hell. All right, so we're going to take 0.6 times 0.1, and we should get 0.06. And then we find this one, which is probability of being from Texas and also being a desktop, 0.6 times 0.2. That's going to be 0.12. And then finally, Texas and or a computer that's going to be a tablet. It's going to be 0.6, all right, times 0.7. 0.6 times 0.7, and what we have is 0.42. Now, once again, you can check your work, my friends. If you add up all these together, they should add to 1. Now let's just check it out. 0.1 plus 0.12 plus 0.18 plus 0.06 plus 0.12 plus 0.42, and it equals 1. Yay, we did it all right. So if we take the sum of all these and it adds to 1, we did it correctly, which we did. All right, so using this information, let's find the probability of a computer is a tablet. Well, figure that out. All right, I'm going to highlight some things. There, what am I looking for? There's my highlighter. All right, for where is a computer a tablet? Well, a computer is a tablet here. All right, computer and tablet, and California and Texas, that's where we have the 2 tablets. So in here, we're going to be taking, all right, 0.18. We're going to add that to 0.42. And so we have is 0.6. So the probability that we have a tablet, all right, is going to be 0.6. So now if we select 4 computers at random from the distribution center with replacement, okay, so they're put back in there, what is the probability that at least one of the computers is a tablet? Now, if you recall, what's the probability of at least one is a tablet? Okay, and that says is that at least one is a tablet. Well, we're going to figure out what is the probability of 1 minus the probability that, all right, none are tablets. Okay, now to figure that out, what we know is that since there is replacement, the probability of selecting a tablet computer, all right, or the probability of not selecting a tablet computer would be the same each time. Now, since selecting a tablet is 0.6, probability of selecting, all right, one that is not a tablet is going to be 0.4. It's going to be the converse of that. And now we're going to do that 4 times. So it's going to be 0.4 times 0.4 times 0.4 using locational probability of location and 0.4, which actually is equal to 1 minus 0.4 to the 4th power. Okay? And so if you do this, 0.4 to the 4th power, all right, what you're going to have then is going to equal 1 minus 0.0256. All right? And when you have that, we should have an answer of about 0.9744. All right, and so that is the probability of at least one being a tablet. All right, pretty good odds. All right. Now, given that a tablet computer is selected, okay, so we are going to say that a tablet computer is being selected. What is the probability that it was made in California? So we want to say it was made in California. So what's the probability of that happening? Well, to find this out, we're going to go back to our probability statement. So what's the probability of being California and a tablet? So we're going back to our, what does a conditional statement actually mean? And the probability of a tablet. Well, we know the probability of a tablet is 0.6. The probability of being California in a tablet, we can go back up here and say, okay, probability of a tablet is 0.18. And so if we take those two, 0.18 divided by 0.6, we'll have 0.3. And that is going to be our solution. All right, so that is an example to check your understanding on how to use, all right, tree diagrams and also general multiplication rule of probability, all right, for independent events, and also when we talk about conditional statements to determine our probabilities. So I hope this helps you out, and good luck and God bless in the rest of your problems.